Good morning everyone, myself Dr. Abhay Bhardwaj. Today we are discussing a topic, Pyrrole. Pyrrole is a heterocyclic molecule that generally contain 5-membered structure. As per the introduction of Pyrrole, it is a 5-membered ring where 4 atoms are carbon and 1 atom is nitrogen, which is generally known as heteroatom of the molecule. The numbering of the pyrrole will start from the nitrogen, or we can say it will start from the heteroatom. The pyrrole was first isolated from coal tar in 1834. It is an aromatic heterocyclic having weak alkaline like order. Means the order of the molecule is just resembles with aniline molecule. It is a colorless volatile liquid which like aniline darken by autooxidation. It has a boiling point around 129 to 131 degrees centigrade. We can say the boiling point of pyrrole is too much high because intramolecular hydrogen bonding are generally exist inside the molecule. Pyrrole has 3 pair of delocalized pi electron where the 2 pairs are generally comes through the carbon and a last one is a nitrogen electron pair. It is a lone pair of nitrogen which will be participate into the internal aromaticity of pyrrole molecule. Here the 3 structures are generally shown inside the picture where the first one is 2H pyrroline where the second position of pyrrole are generally substituted with one more hydrogen. In the second position, we are indicating the presence of double bond which is coming in between third and fourth position. That's why the delta 3 means at 3 position the double bond is going to be initiate on pyrrole. That's why the nomenclature is delta 3 pyrroline. The third structure is pyrrolidine where all unsaturated double bond are not present, means the overall molecule is completely saturated. That's why all the carbon valencies are saturated with 2 hydrogens. Aromaticity of pyrrole. Pyrrole is an aromatic molecule. Pyrrole itself is completely planar pentagon in shape and have molecular dimensions. The 5 sp3 hybridized carbon atom sustain 6 pi electron in the system. The overall atom, we can say the total atom in pyrroles are 5 where the 4 atoms are carbon and remaining one is nitrogen. All are sp2 hybridized in nature and they are sharing the 6 pi electron in their delocalization. Each of 4 carbon atom have 1 electron remaining in a pz orbital. The n atom has 2 electron in p orbital. So dear student, the p orbital electron are generally participate into the aromatic character of the molecule. The p orbital overlap to each other and it gives a total 6 of pi electron which will provide a pi system of the overall molecule. So here we can see inside the figure the 6 pi electron are generally shown here in a dumbbell shaped orbital and one orbital is of nitrogen which is here. So we can say the lone pair of nitrogen are participating inside the molecule, or we can say the molecule aromaticity because it is planar to the pi or unhybridized p orbital of carbon. Now we are coming on the method of preparation. Pyrrole is generally prepared with the help of furan molecule. So here in the presence of catalyst alumina Al2O3, the pyrrole could be prepared from furan. In the first end, the ammonia will be passed through the furon and it will provide the pyrrole molecule, and same if the primary amine will be heated with the furon, then it will provide the substituted pyrrole. The another method is Hansen's pyrrole synthesis, where the beta keto esters are generally undergo in an addition reaction with beta chloroketone, and subsequent presence of ammonia, it will provide a substituted pyrrole. So you can see the subsequent loss of hydrochloric acid and water, it will provide the substituted pyrrole. Now in this structure, the pyrrole is substituted with methyl, then ester, as well as any other alkyl group functionality. The another method of preparation is Pyrrole synthesis, where the alpha amino ketone undergo into the addition reaction with dicarbonyl compound. In the presence of acetic acid and subsequent loss of water, it will again provide the substituted pyrrole. So dear student, you can see in the structure, the pyrrole have the substitution at second, third, fourth and fifth position. The next synthesis method is Pyrrole synthesis, which is very much common method for the pyrrole synthesis. There is a condensation reaction between 1,4-dicarbonyl compound like acetyl acetone with ammonia or a primary amine to form a substituted pyrrole. Pyrrole itself is formed from succinaldehyde and ammonia. So it is a very common reaction, and you can see at the end of the reaction we got the substituted product at C2 and C5 position, that is 2,5-dimethyl pyrrole. The next synthesis is Barthoz-Zard synthesis, where the pyrrole is obtained when an isocyanate molecule, it is here as a substrate, react with a nitroalkene in a 1,4 addition. So the nitroalkene will react with the isocyanacetate molecule in the presence of base. Just because of the subsequent loss of nitro group, again the substituted pyrrole will be obtained as a reaction product. Another method is a distillation of succinimide, where the pyrrole is so obtained by the distillation of succinimide molecule in the presence of zinc dust. The last synthesis, it is from acetylene and ammonia. Here the pyrrole is obtained by passing acetylene molecule and ammonia on red hot tube. So dear student, we are utilizing the 2 mole of acetylene, one is here, another one is here. With ammonia it will pass it through on a red hot tube, so that's why the heating sign is coming here, and it will finally provide the pyrrole molecule. Now the physical property of pyrrole. So the state is volatile liquid. The color of compound is colorless. The order is nutty order like a aniline. The molecule is soluble in alcohol, benzene and ether, or we can say in organic solvent. The boiling point is 129 degrees centigrade. Melting point is minus 23 degrees centigrade. And acid and basicity character. The pyrrole is weakly basic in nature. Chemical property of pyrrole. Pyrrole, furon, thiophene, all are pi successive ring. Pi successive ring means in these all molecules like pyrrole, furon and thiophene, they all possess 5-membered ring, where the 6th atom, 4 carbon and 1 heteroatom are generally sharing the total 6 electron. That's why there is one increased number of electron is present over there in comparison to any 6-membered compound. That's why that have the good electron density over there, and the pi system will generally known as pi excessive ring. Okay. The greater reactivity of pyrrole is toward electrophile. That's why it will generally undergo into the electrophilic substitution reaction. These heterocyclics are pi excessive ring, as I said. Hence, the heterocyclics are less reactive toward the side of nucleophilic substitution reaction. Pyrrole behave as both weak base and weak acid. So you can see the reaction. The pyrrole is behaving here as a weak acid. In the presence of strong base KOH, it is providing the proton, and itself it is making a salt of potassium metal. If we are coming on the depth description of electrophilic substitution reaction, so the pyrrole are generally undergo in a electrophilic substitution reaction, and it is generally prefer the electrophilic substitution at second position. So here we have the two type of attack of electrophile on pyrrole, where the first one is towards the second position and another one is on towards the third position of pyrrole. So dear student, you can see in case of third carbon attack, only the two probable resonating structure are coming here. But in case of the second positional attack on pyrrole, the three probable resonating structure are coming here. So we can say if the canonical form or the resonating structure will be formed in great number, then we can say the molecule will be maximally stable at such type of attacking situation. So now in a nutshell, we can say the C2 attack is most favorable attack as far as electrophilic substitution reaction concerned in pyrrole. So we have some electrophilic substitution reaction examples are here, where the first reaction is nitration reaction, where the nitropyrrole will form. Another one is the sulfonation reaction, where the sulfonation will generally occur in the presence of pyridine and sulfur trioxide at 100 degree centigrade temperature. So 2-pyrrole sulfonic acid will be formed as a yield. The halogenation reaction are generally complete in the presence of acetic acid at 0 degree centigrade temperature, where the 2,3,4,5 tetra-bromopyrrole will be formed as a yield. The last reaction is Friedel-Crafts acylation reaction, which will be complete in the presence of acetic anhydride, and the product will be 2-acetyl pyrrole. Another reactions like alkylation and arylation reaction. The sodium-potassium salt of pyrrole react with alkyl halide to give corresponding N-alkyl pyrrole, presence of electron withdrawing substituent on the pyrrole. So basically, if the electron withdrawing substituent like the nitro group is present over here, then the molecule will undergo into the alkylation and arylation reaction. So N substituted product are generally formed over here. You can see the aryl group is now present at nitrogen. It is N substituted pyrrole. Acylation reaction. So the pyrrole is undergo into the acylation reaction in the presence of acetic anhydride at 200 degree centigrade temperature, and it will give a yield 2-acetyl pyrrole. Same here, in the presence of N-acetyl imidazole, it will give N-acetyl pyrrole. Means now the acetyl group will be substituted at nitrogen once we will utilize N-acetyl imidazole. Another reaction is a Riemer-Tiemann reaction. It's a name reaction. In the presence of a strong base like KOH and chloroform, the pyrrole undergo into the Riemann-Tiemann reaction where it will form substituted aldehyde of pyrrole. So, in the presence of chloroform and base, the pyrrole will go in the formation of pyrrole to aldehyde here. Ring expansion reaction, it is an example of reaction where the 5-membered ring will be expand their structure. So now you can see in this particular example, the 5-membered ring has been converted into the 6-membered pyridine ring. So it is a reaction which will generally proceed in the presence of chloroform and sodium ethoxide. Wolfsmeer-Hack reaction, again it's a name reaction of pyrrole where the pyrrole may be formulated by heating it with phosphorus, oxychloride and dimethylformamide. The intermediate is finally hydrolyzed. You can see here in the presence of mild base, that is sodium acetate, and it will yield the product 2-pyrrole carbaldehyde. Oxidation and reduction reaction. So dear student, in oxidation reaction generally the oxygen atom will be attached to the molecule, and in the reduction reaction generally the hydrogen molecule will be attached to the molecule. So in the presence of chromium trioxide and acetic acid, the dioxo substituted pyrrole will form in the oxidation reaction, and in the reduction reaction same, the zinc metal will be utilized with acetic acid. So the 2,5-dihydropyrrole will form as intermediate, and again with the subsequent use of hydrogen iodide and red phosphorus, the pyrrolidine means a saturated molecule of pyrrole will be formed. Finally, we are coming on the application of pyrrole. So the pyrrole is a structural constituent of heme, chlorophyll, vitamin B12 and bile pigment. Pyrrole ring is also present in the drug tolmetin, ketorolac, which is a NSAID, non-steroidal anti-inflammatory drugs, subnitil, which is an anti-cancer drug, aziliferin, that is an antibacterial drug, antipsychotic drug, and atorvastatin, it is a lipid lowering drug. Pyrrole is widely known as a biologically active scaffold having diversified therapeutic activity such as antipsychotic, beta adrenergic, antagonistic action, anxiolytic action, antibacterial, antifungal, antimalarial and anti-cancer. So we can say the pyrrole is a key molecule, or we can say the basic moiety of many biological constituents which are generally utilized into the human body. We have some diagram of drug like glycopyrrolate, a anticholinergic drug, atorvastatin, it is a lipid lowering drug, tolmetin, it is a non-steroidal anti-inflammatory drug, and ketorolac, again it a NSAID, non-steroidal anti-inflammatory drug. Sunitinib, that is an anti-cancer, elopiprazole, antipsychotic, aziliferin, that is antibacterial, and procyclidine, that is anticholinergic drug. So you can see the pyrrole is present as a basic structure in all the drug material. So that is whole about the pyrrole as a heterocyclic molecule. Hope this video lecture will help you. Thanks.